This is assignment number 7 of alcohols, phenols, and ethers. First is nomenclature. CH3, O, CH, C2H5 twice. 1, 2. This is the longest chain of 5 carbon atoms, and methoxy is at carbon number 3. So IUPAC name is 3-methoxypentane. Next, CH3, CCl, CH3, CH2OH. This is the longest chain. CH3, CH3, CH3. Yes, this is the longest chain of 4 carbon atoms. IUPAC will be 2-chloro, 2,3-dimethyl, 1-butanol. 2-chloro, 2,3-dimethyl, 1-butanol. And last is very simple one. This is the structure of last compound. This is 2-methoxypropane. 2-methoxypropane. Coming to fill in the blanks. First sequence. Ethylene is the common name of ethene. I'll repeat, ethylene is the common name of ethene. Ethene reacts with HCl to give chloroethane. Chloroethane with aqueous NaOH gives ethanol. Alcohol with sulfuric acid at 100 degrees centigrade. See, below 140 degrees centigrade, I told you, product obtained will be a symmetrical ether. So in this case, product will be diethyl ether. This on reaction with HI will give two products. One will be alcohol and the other will be alkyl halide. It will be ethanol and iodoethane. Second sequence. A with aqueous and A with NaOH solid heat hydrolysis. This is one of the methods of preparation of phenols. A is sodium salt of sulfonic acid. This is taken in the solid form. Now, this will lead to formation of phenol. Phenol with zinc dust undergoes reduction to give benzene. Benzene with chloromethane aluminum chloride as Friedel-Crafts alkylation will give toluene. Toluene with chlorine HNO, this is side chain chlorination, will lead to the formation of benzyl chloride. Benzyl chloride with KCN, this is NSR, will lead to the formation of, common name of this product is benzyl cyanide. IUPAC is 2-phenyl ethane nitrile. 2-phenyl ethane nitrile. Third sequence, benzene with chlorine in the presence of FeCl3. This chlorination on the benzene ring will give chlorobenzene. Next, Dawes process equal to B means we have to write all the conditions for Dawes process. It will be aqueous NaOH, 623 Kelvin, 300 atm pressure, followed by hydrolysis. All that will be the answer for B. And this leads to the formation of phenol. And phenol with nitrating mixture will lead to formation of picric acid. So last answer is 2,4,6 trinitrophenol. Fourth sequence, A plus B leads to formation of methyl isopropyl ether. This is Williamson synthesis, and I told you for the preparation of unsymmetrical ether by Williamson synthesis, we should start with the smaller chain halide and longer chain or a branch chain salt of alcohol. So it will be halomethane and sodium salt of 2-propanol. This ether on reaction with HI, again I told you, this will lead to formation of smaller chain halide and longer or the branch chain alcohol, except if one of the chains is tertiary. That is something different, I told you. So this will give iodomethane and 2-propanol. Next sequence. At the end, we are given benzaldehyde. Benzaldehyde is obtained by heating G with zinc dust. It means G is salicylaldehyde. And the salicylaldehyde is obtained by last two reactions, and these two reactions combined together are nothing but Rimer-Timman reaction. So F will be sodium salt of salicylaldehyde, and before that D and E. D is phenol and E is chloroform. E is chloroform, D is phenol. Now, phenol is obtained by the reaction of C with oxygen dilute sulfuric acid. C is cumene. C is cumene because cumene with oxygen gives cumene hydroperoxide. Hydroperoxide with dilute sulfuric acid gives phenol and acetone. Cumene is obtained by the reaction between A and B with H3PO4, a special Friedel-Crafts reaction. If you remember, I told you benzene and propene. So starts with this, and after that, this is A, B, C, D, E, F, G. Explain why. First question is to be explained. Ethanol is a liquid while isomeric dimethyl ether is a gas at room temperature. Reason is there is extensive hydrogen bonding in ethanol, due to which its boiling point is high and exists as liquid at room temperature. What happens when anisole is treated with bromine and acetic acid? Acetic acid is a solvent in this reaction. We'll write that bromination takes place to give a mixture of ortho and para bromoanisoles. Write a balanced equation for that. Reaction vessel during fermentation is left open. So if vessel is left open, then ethanol formed will get oxidized in the presence of air and lead to the formation of acetic acid. Distinguish 2-methyl, 2-butanol, and 3-pentanol. If you have thought which distinguishing test you want to use, please share with me which one can be used. Anyone?
Iodoform test.
Yes, I wanted to listen to that only. Iodoform test cannot be used because none of the two compounds contains required group for iodoform test. Iodoform test cannot be used. We can use Lucas reagent test. That's the only test which can be used because one is a tertiary alcohol, the other is secondary alcohol. Remember, 3-pentanol does not contain required group for iodoform test. Lucas reagent test is the only one. Phenol and ethanol, there are 3 tests which can be used. We can use ferric chloride test. We can use bromine water test. Both will be positive by phenol. Then we can use iodoform test, which will be given by ethanol, not by phenol. So any one of these tests can be used. Coming to conversions. 1-butane into 3-tertiary alcohol. Add any HX in excess according to Markovnikov rule. This will give 2,2-dihalobutane. With aqueous NaOH, this will give a ketone. With methyl grignard, you'll get final product. Right? In fact, there's a reaction to directly convert this alkyne into 2-butanone. This is the reaction you studied in 11th standard, and we'll be studying this reaction again in 12th standard in aldehyde ketones. That is hydration of alkynes in the presence of 42% sulfuric acid, 1% mercuric ions. Maybe you have forgotten by now. I'll teach in the next chapter. 1-propanol into propyne. 1-propanol into propyne. First reaction is dehydration. Concentrated sulfuric acid 160 to 170 degrees centigrade. React with bromine water. We get 1,2-dibromoethane. And after that, alcoholic OH, dehydrogenation. Alcoholic OH can be used, or you can use NaNH2. Sodamide can be used. 2-methyl propanol into tertiary butyl alcohol. First reaction is reduction with lithium aluminum hydride or any other reducing agent. Will get alcohol, then dehydrate it. Sulfuric 170 degrees centigrade. After removal of water, now add water according to Markovnikov's rule. This is hydration of alkyne or hydration of alkene with sulfuric acid followed by hydrolysis. Chloromethane into methyl acetate. React with aqueous NaOH. Halide will give alcohol. Then react with acetyl chloride or acetic acid with proper conditions, of course. If you want to use acetyl chloride, then you'll have to use pyridine. If you react with acetic acid, then concentrated sulfuric acid has to be used. But there is one reaction I taught you in alkyl aryl halides. We can directly convert chloromethane into this ester. Does anyone remember? This is a reaction with sodium or silver carboxylate. Sodium salt or silver salt of carboxylic acid will give this product. We can convert in one step. Next question. A straight chain, let me write here. A straight chain polyhydroxyaldehyde. It has CHO group and it has a straight chain. According to the formula, it has 5 carbon atoms. 1, 2, 3, 4, 5. Polyhydroxy. It means it has minimum 2 OH groups. How many OH groups we don't know, but minimum 2. And where are they present? Even that we do not know. Gives C13H18O9 on reaction with acetyl chloride. Identify A. Now this on reaction with acetyl chloride. See, if there is one OH group, then H and Cl will be eliminated as HCl. This is esterification. And this will form ester. It means if there is one OH group in the reactant, there will be increase of 2 carbon atoms in the product. And if you compare formulas of reactant and the product given, there's a difference of 8 carbon atoms. 8 carbon atoms have increased. Increase of 8 carbon means this type of 4 groups will be added. For 4 groups, there should be 4 OH groups. It means in the reactant, there are 4 OH groups. Now, if you remember, I told you more than one OH group cannot be attached to the same carbon atom. So these 4 OH groups, they are present on 4 different carbon atoms. So the compound is this. So compound is 2, 3, 4, 5 tetrahydroxypentanol. This is the compound. Next. Now that was the last question. So we have finished the assignment.